and we'll get started here. So let me pull up a first problem I found. So you might be asked to simplify something like this. And to start, you have to know your trig identities. There's 3 identities that they generally have when you're looking at squareds. Let me see if I can pull that up here for you. Yeah. So here's a reference sheet I really like. I'm going to send it to you by chat. I would recommend printing that out. It's got all the identities you'll need for this course, but the ones we're focusing on are the Pythagorean identities. Let me snip those in. So there are 3 Pythagorean identities. So you may have seen the first one, sine squared plus cosine squared, in the past, but the other 2 are kind of less commonly used, tangent squared plus 1 and 1 plus cotangent squared. You can see that they're used to reduce a problem like this on the left here. So the numerator becomes secant squared. Okay, and the variable doesn't matter. Like here it's theta, in your problem it's t, so you're going to use t. Now on the bottom, you have 1 plus cotangent squared, which becomes cosecant squared t. Okay, so you may want to ask your instructor if you're going to have to remember these, or if they're going to be given to you, or if you're going to have a reference sheet. Really makes a difference in how you do the problems. Any questions on that so far?
No.
Nope. Okay. So this is not done though, and I think one of the hardest things about these problems is like, when are you done? Well, you try to keep reducing as much as possible, and we've gotten rid of the plus ones, but it's like, well, secant over cosecant, is that something? There are also these reciprocal identities. Let me snip those in. Hopefully you've seen these in class. So these are potentially useful here. So secant squared is really, if we look at the reciprocal ones here, it's really 1 over cosine squared. Okay, and then cosecant squared is 1 over sine squared t. Okay, so why does this matter? Because secant squared over cosecant squared becomes 1 over cosine squared t over 1 over sine squared t. Whenever you divide by a fraction, you can then multiply by the reciprocal, like this. And so this produces sine squared t over cosine squared t.
Okay.
And that's where you're supposed to say, oh, I know what that is, because sine over cosine is, I'll snip that in, yet a few more things to remember. Sine over cosine is tangent. So this becomes tangent squared t. Does that look like something you've done in class, or does that just look totally unfamiliar?
It looks like something we've done in class.
Okay. Now what do you think about this process? Like how, give me some feedback on this. Is this easy? Is it hard? Is it nice to have the identities? What are you noticing about this?
I don't think this is hard. I think odd and even identities are like, I don't get them at all.
Okay, good. Let's do those then, because
Yeah.
this was going to be kind of a lot of nonsense if it wasn't clear. So that reference sheet I just sent you, it does have the odd and even identities on it. Although for some reason, there they are. The sheet looks different. Somebody must have updated it. So here's your even odd formulas. Okay, so for now, let's just assume you have these, and then we'll talk about how you can remember them without memorizing a bunch of stuff. So you'll notice trig is heavy on formulas, heavy on memorization.
Mm-hmm.
Okay, So the idea is, let's say I wanted you to find the sine of minus pi over 3. Okay. What you're supposed to recognize is, oh, this is a negative. And if you have that even and odd formula, and you can pull that, it's on page 2 of that reference sheet. It says that the sine of minus theta equals minus the sine of theta. So why is that useful? Well, that means that that this problem right here is really minus the sine of pi over 3. Now, how much of your unit circle do you remember from geometry or a previous class?
0.
Yeah, not much, right? You don't need to know your unit circle when you're lifeguarding, because nobody's going to ask you this,
Yeah.
which is good. So that's on page 3 of the unit circle. When you're in class or when you're doing homework, it would be good to have this just next to you, printed out. The more you look at it, the more it'll sort of slowly help you build it back. But if you recall, sine is the y value. So what is the y value here on the unit circle?
Square root 3/2.
Right. So this becomes negative square root 3 over 2. So this is kind of the first way that you will use the even and odd properties of sine and cosine. All right, so let's do another here. So let's say I asked you for the cosine of minus pi. And if you have your reference sheet, you will see that the cosine of minus theta is equal to cosine of theta. So this is really the cosine of pi. Now I'll snip this in again, but if you got your unit circle up, you can just go right to pi. Pi is right here, 180 degrees, and cosine is the x value. Okay, so x is the cosine, y is the sine. What is the x value at this point here?
-1.
-1. So this becomes -1. Any questions on that so far?
No?
Great. So we'll do some more difficult ones next. The first one would be something like this, like asking you what's the tangent of minus 3 pi over 4. Right. And there's a couple of ways to do this. One is to say, okay, this is really the sine of minus 3 pi over 4 over the cosine of minus 3 pi over 4. And then just like we've done for two examples here, the sine becomes negative the sine of 3 pi over 4. And cosine becomes just the cosine of 3 pi over 4. So all we're doing with these even and odds is we're like figuring out what to do with this negative. Either it comes out here or it goes away altogether. And it's all based on this list here. Okay, so if you look, do you have that unit circle up?
Yeah.
Okay, can you tell me the sine of 3 pi over 4?
It would be square root of 2/2.
That's right. So it'd be negative square root of 2 over 2. And then the cosine 3 pi over 4 is negative square root of 2 over 2. Since they're the same, this becomes 1.
I have a question. So with
Of course.
sine, it was sine, does it correlate with x? Like, I think tangent correlates with y, if I'm not wrong. I don't know.
No, so yeah, so I was gonna jump into that next, which is like, well, why, like, how do you know which ones are negative, bring it out or go away, like from this list? So if you give me a moment here, I think I can explain that to you. We kind of did tangent already because tangent of minus x is sine minus x over cosine minus x. And that negative comes out for sine, but it goes away for cosine,
Right.
which is why it becomes minus tangent x. So there are some similarities between sine and tangent.
Okay.
Okay, now what I want to address though is why is cosecant the way it is, which is like sine, because you really only need to know sine and cosine to do the rest of them. Like once you know one, it leads to the other. So the cosecant of minus theta, cosecant is really 1 over the sine of minus theta. That's a reciprocal property. And so this becomes 1 over, well, sine of minus theta given here becomes minus sine of theta. That negative goes to the numerator, so this becomes -1 over sine theta. And just going backwards, 1 over sine theta is cosecant theta. So that's why it works out that way, where sine and cosecant are the same. Because cosecant is really a sine in disguise.
Okay.
And that's why similarly here, that's why cosine goes with secant, sine goes with cosecant, sine goes with tangent, and then tangent goes with cotangent. So you really only need to know these two to find the other ones.
Okay.
But you have to be very like solid on that. You have to be like, oh yeah, cosecant's really sine. Sine is this way, so cosecant is this way. Cosine, secant is really cosine. Okay. Oh, tangent is sine over cosine. Sine is negative. Cosine's not, so it's negative. Things like that. That's how you do it. Do it quickly. But I mean, you don't need to be fast. You just need to know how to work some problems like that.
Yeah.
Pretty exciting, right?
Oh yeah.
Even odd trig identity examples worksheet. All right, let me see if I can find some practice problems. All right, here we go. All right, so here's a problem I found that might be useful to kind of understand what we're doing. It would say to simplify the following. Simplify the following. So it's kind of like that first problem we did, plus I'm throwing in a negative in here. All right, so the first thing is to deal with the fact that there's a negative inside the cosine. So how does that change everything that I'm showing here? How does this negative inside parentheses affect cosine?
Um. Wouldn't it make it I
Okay,
don't know.
so you can go back up, right? You've got this list here. Cosine of minus theta becomes what? What do you see here?
Positive cosine theta.
Yeah, so the negative just goes away. Now, maybe
Yeah.
where it's unclear is that like, well, what do I do with this subtraction out in front? It just comes down. It comes down. But this part that I'll highlight here in this purplish color, this right here becomes cosine theta. Like that. Does that make sense? I mean, it's a pretty straightforward thing, but
Yeah.
okay. All right, now the next thing to do here is to distribute this cosine theta to both of these terms. So this becomes cosine theta secant theta minus, do you remember from class when you take a cosine and multiply it by itself, what does that become?
It stays the same.
So it ends up being cosine squared theta. It's like x times x becomes x squared. Now, when you're simplifying, it's supposed to become simpler, and I'm not sure I'm not sure that has happened yet. Would you agree this doesn't necessarily look any simpler than the beginning?
No.
No. So another strategy is to rewrite anything that's not sine and cosine into sine and cosine. Okay, so the secant theta, how can you write that as a sine or a cosine? And think back to your reciprocal identities. Get those in here, snipped in here. Here we go.
Oh, you can do 1 over cosine to the.
Yes. So cosine theta becomes 1 over cosine theta minus cosine squared theta. And anything times 1 is itself, or maybe you already see that they cancel.
Mhm.
But the 1 is left over. So this becomes 1 minus cosine squared theta.
Yeah.
All right. And you might think, well, that's better. Are we done? It's kind of like factoring. Like, remember factoring, you would do something and then you think you were done, but then there was like another thing to do to factor it out completely. It's kind of the same deal here. You have to keep going. And it's like, well, how do I know when I'm done? And I don't have a good answer to that. But this one we're not done with. There is a Pythagorean identity that we can use. We're gonna look at this top one here. Any idea how to use this top Pythagorean identity for
Um,
I'm just asking because I don't know how much you've seen in class or what you're
what I've seen is that my teacher usually gets rid of the equation and just does the identity.
okay. So what you can do, you have two choices here. You can either solve for cosine squared theta,
Mm-hmm.
or you can solve the whole thing for 1 minus cosine squared theta. So what I mean by that is if you subtract cosine squared theta from both sides,
Mm-hmm.
you get sine squared theta equals 1 minus cosine squared theta. So you can actually substitute sine squared theta for everything. Like this becomes sine squared theta because they're the same. Now, if you don't like that, maybe you don't like that. Let's say you go back to this identity, the Pythagorean identity, and let's say instead you're like, no, let me solve it for cosine squared theta. So that means you're going to subtract sine squared theta from both sides. So cosine squared theta is 1 minus sine squared theta. So we're going to replace cosine squared theta with 1 minus sine squared theta. So wherever you see a cosine theta, you're putting a sine squared theta like this. And you may be like, hey, what do I do here with this? So you distribute the negative, and you get 1 minus 1 plus sine squared theta. And you see that the ones cancel and you get sine squared theta.
Okay. So this whole like unit is just plugging in equations.
A little bit, yeah.
Okay.
So the basis for this is it's a little bit the basis for this is like proofs a little bit. If you recall doing proofs in geometry, you sometimes substituted in for things, and then it worked out so that you made equalities and stuff like that.
Okay.
It might be now that you're like, man, last semester wasn't as bad as I thought it was. Um, okay, so let's look at another problem. So this is another kind of it's both a it's a simplify. We would just say the instructions just simplify, but you're doing two things. You're using the even and odds, and then you're going to use some identities to figure out how to simplify this further. So if you have access to that reference sheet, could you tell me how to reduce each of these, the cotangent minus theta, the cosine minus theta, and the sine minus theta?
Cotangent minus theta would be negative cotangent theta.
Good.
Cosine would be cosine theta.
Okay. What about the last one
And
there?
sine would be negative sine theta.
Good. So you've reduced this much more complicated thing down to this, which is great. This one requires a kind of a little bit of a different approach, which we'll see in a moment. So one of the strategies to simplify is you I don't want to say this. You write everything in terms of sine and cosine. Okay, so kind of saying it another way, if it's sine or cosine already, you're fine. But this cotangent, you have to convert that to some combination of sine and cosine. Can you tell me what that is? What is cotangent in terms of sine and cosine? It's at the top of page 2. Let me snip it in here.
Oh, it's cosine theta over sine theta.
Yes, so it's minus cosine theta over sine theta, cosine theta minus sine theta, like this. So if you like Quizlet, I'm sure there's a good one for all these trig identities. Specifically like the reciprocals and the tangent and cotangent. You really want to get fast at those to be able to do these problems well. Or do you have the same teacher this semester as last?
Unfortunately.
Any chance to change?
Nope.
Okay. Sorry to hear that. I know sometimes they have it at the same time with teachers. So she's going to be more challenging from what I remember. Which means she's like, yeah, you should know this stuff. And that's where you've got to just put in a little extra effort here and I'll help to make it as simple as possible. Okay, so our goal is to simplify. We have not really simplified anything yet. We've actually made it worse. We're going to multiply the cosine of the cosine. So it's minus cosine squared theta over sine theta minus sine theta on the right here. I'm going to put a 1 on the bottom. You can always write a sine or cosine as divided by 1. And this is where there's a little bit of a link to what you did last semester. We're going to make a common denominator here of sine theta. So you're going to multiply the top and bottom by sine theta. And it's a common approach that you might see. So this becomes minus cosine squared theta over sine theta minus sine squared theta over sine theta. And since the bottoms are the same, you can combine the tops. So this becomes minus cosine squared theta minus sine squared theta. And again, it still doesn't look all that simplified. Like I would say you could even say, it's still as bad as before. There is a Pythagorean identity though in play. Can you tell me how the top is related to this over here?
It has sine and cosine.
Sine squared and cosine squared. Yeah. Now these are negative though,
Yeah.
right? And these aren't negatives. So there's a couple of choices here. The best choice is if you could say, oh, I can factor out a negative from both of the top two. So it becomes cosine squared theta plus sine squared theta. Now, this part that I'm highlighting in purple and this that I'm highlighting in purple, are they the same?
Yeah.
They are. There. The order doesn't matter when you're adding. So instead of the purple part, you can put 1 in. So this whole thing in the top becomes minus 1 over sine theta. And then what does this reduce to? What's the reciprocal identity for this one?
Um,
It's on page 2, kind of at the top of that reference cheat sheet that I sent you.
yeah. Oh, cosecant theta.
Yes, this becomes minus cosecant theta. Yeah. All right, now I'm just looking at your notes again because I'm trying to make sure that we cover a bunch of stuff. I think I'd like to solve some trig equations now, if
Okay.
that's okay with you. Going out to the internet here to find some. boy, these are all too difficult. Let me make one up here. Okay, let's say I asked you to solve for the sine of x. 2 sine x minus the square root of 3 equals 0. Okay, so this one would say to solve, and we'll make it kind of straightforward. We'll say it's from 0 to 2 pi, which means that you only have to look on the unit circle. You don't have to try to extend your answer beyond that. All right. Now from class or your notes, do you remember how to proceed with a problem like this? Maybe you didn't get up to this, but I figured I'd ask.
Oh, if I'm thinking correctly, you put, instead of sine, you put W.
Yeah, so you can make a substitution.
Yeah,
Now, did your instructor say to use W or U?
W.
Wow, that's weird. Okay, 2W minus the square root of 3 equals 0. So U is the most common substitution in math. That's why I have no idea why they're using W, but we'll use it. Yeah. All right. Well, you can ask in class why you don't use U. So you're going to add square root of 3 to both sides. Okay, so you get 2W equals the square root of 3. Divide by 2, divide by 2. So you get W equals the square root of 3 over 2. And this is where you need to back substitute. So because you said W is sine X, you now go backward and say, okay, sine X is W. And you're solving this equation. Okay. So to do this, you have to know your unit circle. Okay, there are 2 places on your unit circle where the y value, this is what this is saying, is the y value is the square root of 3 over 2. So there's 2 places on your unit circle where this happens. There's one in the first quadrant and one in the second quadrant. Could you give me those angles, please? If you've got that reference sheet, it's page 3.
It's 2 pi over 3 and pi over 3.
Very good. Okay. What did your instructor say about the unit circle? You need to know it. You'll get it.
You need to know it.
Oh, it's painful. It's like,
Yeah. Yeah.
you think you can make a deal like, hey, can we get it on, the test if we bake you some cookies, or go to Crumble Cookie and get you some, anything like that? Because this is going to be hard. It's going to be hard if you don't know the unit circle.
Yeah. Well, she's like the type to be like, well, that sucks. And she's like,
So
and
not a lot of sympathy for the student here.
no, not at
Okay.
all.
All right. All right, let's look at another one.
Okay.
The square root of 2 sine x. Wait, will you do cosine this time? Cosine x plus 1 equals 0. And what I'd like you can make this substitution. So we'll say W is cosine x. Can you solve this for W, please? And tell me what you come up with.
Okay, so I don't know if I'm like. So I subtracted 1.
Okay, that's good.
Yeah.
Square root of 2 times w equals -1.
And then, oh. Oh, I was thinking about solving it a different way. Never mind.
Divide by the square root of 2.
Yeah.
And then if we back substitute, if we say, okay, we're not really solving for w, we're solving for cosine x. So this is now the x value. So there are 2 places on the unit circle where this is true. But the problem is when you look at your unit circle, you will never see this right here, the way it's written, -1 over the square root of 2. And the reason is that it's not rationalized.
Mm.
Okay, so this is like something that the teacher might do, because you're supposed to know to rationalize. You're supposed to know that you're not allowed to have a square root in the bottom.
Right.
Okay, so when you rationalize, okay, that will show up now on the unit circle. So square root of 2 times square root of 2 is square root of 4, which is 2. So there are 2 places on the unit circle where the x coordinate is -√2 over 2. Can you give me those 2 places?
It would be 3 pi over 4. Oh, never mind. 7 pi over 4 and pi over 4.
So we're looking at the x
Oh,
coordinate.
I did have it right the first time. Never
Yeah,
mind.
3 pi over 4 is correct.
Yeah, and then 5 pi over 4.
Yes. That unit circle is really valuable. It's like, okay, it gives me a chance to figure this out and have a shot at getting it right. Otherwise, it's just really hard to do here. Okay, you ready for some more examples?
Yeah.
All right. Next problem here, we'll go. I don't want to make these too difficult. Let's go. Yeah, let's do this. 4 sine squared theta minus 3 equals 0. So at some point, you don't want to make this substitution because it's unnecessary. You're just putting it back in. When you're done, your goal here is to solve for sine theta. So you're gonna add 3 to both sides, divide by 4. Okay, but you're not there yet, right? You have sine squared theta on the left, not sine theta. Like it's the analogous is like it's x squared, not x. Okay, so you undo the square with a square root. So you take a square root of both sides, but super important to remember it's plus or minus. This becomes sine theta equals plus or minus the square root of 3 over 4. Now, if you look on your unit circle, there is no square root of 3 over 4 on your unit circle. So you have to remember properties of roots. Square root of 3 over square root of 4. Square root of 3 is unknown, but square root of 4 is 2. So there's really 2 equations that you're solving now. You're solving for sine theta equals positive square root of 3 over 2. Sine theta equals minus square root of 3 over 2.
Got it.
So in terms of your unit circle, you have to then be like, okay, it's where the y value is √3 over 2, or where the y value is minus √3 over 2. There is more than one answer. There's more than 2 answers. So if you got your unit circle up, could you, again, we're looking for the Y value. Could you give me those answers? And it's usually best if you can do them in order from counterclockwise from 0.
Yeah. 5 pi over 6.
How about we go in counterclockwise from 0? So like if you, what I'm asking, I'll snip this entire unit circle in because this is really important. Because it helps in terms of like doing it the right way. You want to look this direction.
Oh, I started at the top 0. Never
Yeah,
mind.
so you're like, okay, square root of 3/2, square root of 3/2, minus square root of 3/2, minus square root of 3/2. And that gives you your answers. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. They do not always work nicely like that, where they increment by the same amount, or what appears to be the same amount. You cannot pattern them. You can't like, oh, I got the first two, so therefore I know how to get the last two.